The year is 1945. The world is at war. But something is about to change, something that will redefine the nature of power itself. This is the story of the atom bomb. It is a story of scientific discovery, of engineering prowess, and of the profound moral dilemmas that arise when humanity unlocks the secrets of the atom. Join me and let's explore this pivotal chapter in human history. To understand the atom bomb, we must first journey into the heart of matter, to the atom itself. Atoms are incredibly tiny, far smaller than anything the human eye can see. Imagine an atom as a miniature solar system. In the center you have the nucleus containing protons and neutrons. Whizzing around the nucleus are electrons much like planets orbiting a star. It is within this tiny realm that the atom bomb's power lies dormant, waiting to be unleashed. The key to the atom bomb is a process called nuclear fission. This process is fundamental to the operation of nuclear reactors and atomic bombs alike. It involves the splitting of heavy atomic nuclei, which releases a tremendous amount of energy. Fission occurs when the nucleus of an atom, often uranium or plutonium, is split apart. This splitting is usually initiated by a neutron colliding with the nucleus, causing it to become unstable and break into smaller parts. This splitting releases an enormous amount of energy. The energy released is in the form of kinetic energy of the fragments, which is then converted into heat. This heat can be harnessed for power generation or, in the case of a bomb, to create a massive explosion. Imagine splitting a single piece of firewood. The energy released is relatively small and manageable. Now imagine splitting 1 billion pieces of firewood at the same time. The energy released would be immense and overwhelming, much like the energy released in a nuclear fission reaction. That's the difference in energy released between a chemical reaction, like burning wood, and a nuclear reaction, like fission. A chemical reaction involves the rearrangement of electrons, while a nuclear reaction involves changes in the nucleus itself. But there's a catch. To create an explosion, you need a chain reaction. This means that the neutrons released by one fission event must go on to cause additional fission events, creating a self-sustaining series of reactions. This chain reaction is what makes nuclear fission so powerful and potentially so dangerous. The Manhattan Project and the birth of a weapon. The Manhattan Project, a top-secret American-led effort during World War II, brought together some of the brightest minds on the planet. Scientists from various disciplines, including physics, chemistry, and engineering, collaborated in an unprecedented manner. This monumental project was driven by the fear that Nazi Germany was also working on a similar weapon. The stakes were incredibly high, and the pressure was immense. Their goal to harness the power of nuclear fission to create a weapon of unimaginable destructive force. Nuclear fission, the process of splitting an atomic nucleus to release energy, was a groundbreaking discovery. The scientists worked tirelessly, often around the clock, to solve complex problems and overcome numerous technical challenges. In the deserts of New Mexico, the first atomic bomb was tested, forever changing the course of history. The test site, known as the Trinity Site, was chosen for its remote location. On July 16, 1945, the world witnessed the dawn of the atomic age. The Trinity test, as it was known, unleashed a blinding flash and a mushroom cloud that stretched miles into the sky. The explosion was more powerful than anyone had anticipated, and it marked a significant turning point in modern warfare. The atomic age had begun. The success of the Manhattan Project not only ended World War II but also ushered in a new era of nuclear power and weaponry, forever altering global politics and military strategies. The atomic age legacy and responsibility. The bombings of Hiroshima and Nagasaki, Japan, in August 1945 demonstrated the devastating power of the atom bomb. These events marked a turning point in human history, showcasing the destructive potential of nuclear weapons. The immediate aftermath was catastrophic, with tens of thousands of lives lost in an instant and many more suffering from the long-term effects of radiation exposure. The world watched in horror as entire cities were reduced to rubble. The sheer scale of the destruction was unprecedented, leaving a lasting impact on global consciousness. The images of flattened buildings and charred landscapes became symbols of the terrifying power humanity had unleashed. The atomic bombs ushered in a new era, one defined by both the promise of technological advancement and the specter of nuclear annihilation. Scientists and policymakers grappled with the dual-edged sword of nuclear technology, which could be used for both energy production and unparalleled destruction. The Cold War era saw an arms race, with nations amassing nuclear arsenals capable of obliterating the planet many times over. It is a legacy we wrestle with to this day, a stark reminder of the awesome responsibility that comes with wielding the power of the atom. Modern society continues to debate the ethical implications of nuclear energy and weapons. Memorials dedicated to the victims of Hiroshima and Nagasaki serve as poignant reminders of the past, urging us to reflect on the choices we make and the future we wish to build. Thanks for watching. Please like, share and subscribe our channel for more video.